Welcome once again to the video lessons on theorems. What you see on the screen is the end of the review of theorems. I'd already discussed 5 important theorems and have told you that those theorems you need to know how to prove them. In this video lesson, students, you will be looking into the theorem opposite angles of a cyclic quadrilateral are supplementary. I have proved it. No doubt it was done in the earlier lessons also. But in this video lesson, I'm going to take you through the important components or important properties that you need to know in order to prove that theorem that opposite angles of a cyclic quadrilateral is supplementary. Have a look. Now, these are the 5 important theorems, out of which these 4 have already been done, and 10.3 and 10.4 are important. Now, 10.11. You need to know how to prove this also. The sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree. The proof of this is not there in the textbook, but I have proved it for you all, and I want you to make a note of it and write it down in your notebook. Okay, but before we begin with this proof, let us look into the things that you need to know in order to prove this theorem. Now, look at this diagram. In this circle, angle AOB is the central angle. The angle which is formed in the center of the circle, that angle is called as the central angle. Then this arc AXB is the minor arc, and arc APB is the major arc. You have done this. We have revised all this in the earlier video lessons. The minor arc is 120 degree. It is already given here. That is arc AXB is 120 degree. And arc APB, which is the major arc, is 240 degree. 240 degree plus 120 degree gives you 360 degree, which is the angular measure of a circle. It is the measure of the circle, which is 360 degree. Now, if angle AOB, the central angle, is 120 degree, then the corresponding minor arc will also be 120 degree, because the measure of the corresponding arc is always equal to the measure of the central angle. So whatever is the central angle, what corresponds to it? AXB corresponds to it. Why does it correspond to it? Because see, starting letter A, ending letter B, you get an arc like this, and you have an angle like this AOB. So if this is 120 degree, this arc is also 120 degree. If this angle is 140 degree, then this arc will also be 140 degree. Now at the same time, there is an angle APB. What does this angle APB represent? Let us have a look at the next slide. You have done this theorem. The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So the meaning is, in this circle, AOB is the central angle, which is the corresponding minor arc. This is the corresponding minor arc, AB. I have also written it as the intercepted arc. When does it become the intercepted arc? Look at this angle APB. Isn't this angle APB on the circle? So this angle APB is the inscribed angle, and it is intercepted. It is formed by which arc? It is intercepted by arc AB. Okay, because if you look at this arc AB, it is forming an angle on the circle. And which is the angle that is formed on the circle? It is APB. So this angle APB is called the inscribed angle. And the inscribed angle will always have an intercepted arc. That is, which arc forms that angle. So this is the arc AB. Okay. Then you have the central angle 120 degree. Now we did this. You've already learned this property. If the central angle is 120 degree, what will be the corresponding minor arc? That will also be 120 degree. What is the reason? The central angle is equal to the measure of the corresponding minor arc. Whatever is the central angle, the same will be the measure of the corresponding minor arc. So what is the measure of this arc AB? It will be 120 degree. So if this arc is 120 degree, what will be this inscribed angle? 60. Why will it be 60? Because you know that this angle P is half of angle O because of this property. And O, this angle AOB, is also equal to this arc. So in other words, this angle APB is half the measure of the intercepted arc. I want you to understand these terms. What is the inscribed angle? What is the central angle? And what is the meaning of the intercepted arc? Let us look at another example. Now, there is an angle on the circle. Which is that angle on the circle? That is angle AOP. And I have written down the measure of that angle. Suppose it is 60 degree. This is called the inscribed angle. Now, isn't this angle AOB formed by an arc? Which is that arc? AB. Okay, see, I've drawn these arrows. It's just for your understanding that this is the intercepted arc. So you will always have an inscribed angle and you will get an intercepted arc. In simple words, inscribed angle is an angle which is there on the circle, and this angle is formed by which arc? It is this arc that is making this angle AOB. Okay, is that clear? So you have the inscribed angle and you have the intercepted arc. So what is the relation between this 60 and 120? Can I say that the inscribed angle is half the measure of the intercepted arc? Because 60 is half of 120. And at the same time, I repeat, if this is the central angle, what will be the measure of this angle? It will be 120, because whatever is the central angle, same is the corresponding minor arc. See here, inscribed angle, intercepted arc, and this is the property. Inscribed angle AOB is half the measure of the intercepted arc AB. Clear? So to sum it up, AOB is the inscribed angle, and this inscribed angle is half the measure of this intercepted arc AB. Okay, and also this angle AOB will be half the measure of the angle at the center. Now, what is a cyclic quadrilateral? You have done problems based on cyclic quadrilateral in the first periodic. You had questions based on that. So you know that ABCD, this quadrilateral is a cyclic quadrilateral, and the opposite angles of this cyclic quadrilateral, they are supplementary. Okay. Now, let us prove that the opposite angles of this cyclic quadrilateral are supplementary. In order to prove this, you need to know few things. What is an inscribed angle? What is an intercepted arc? Okay, so let me revise it once again. ABC. Is this angle B on the circle? Yes. So this angle ABC is the inscribed angle, and it is formed or it is intercepted by which arc? Take the opposite one. So it is intercepted by arc ADC. Similarly, look at the opposite angle. Look at angle D. Angle ADC is this angle. It is inscribed in the circle. So this inscribed angle ADC, it is formed or it is intercepted by which arc? You have to take the opposite arc. So it is intercepted by arc ABC. I hope it is clear. Similarly, look at angle BAD. Is it not inscribed on the circle? It is on the circle. So this angle BAD is inscribed angle. It is intercepted by which arc? Take the opposite arc. It is intercepted by BCD. Same way, angle BCD, this angle is intercepted by which arc? Intercepted by arc BAD. All this was done in the earlier lessons. This is just a revision. Now let us look into the theorem. Opposite angles of a cyclic quadrilateral is 180 degree. So you need to draw a cyclic quadrilateral and write down what is given and what you need to prove. Okay, now let us start with the proof. The clue here is you decide which two opposite angles you want to take. So let us take opposite angle D and opposite angle B first. Okay, so you make a statement like this. Angle ADC is inscribed. Okay, so it is inscribed angle and it is intercepted by which arc? It is intercepted by arc ABC. Okay, and you know the property. The inscribed angle is half the measure of the intercepted arc. So measure angle ADC is half measure arc ABC. This will be statement 1. It is inscribed angle theorem. Okay, or you can just write inscribed angle is half the measure of the intercepted arc. Now take the opposite angle. Opposite to D is B. Angle ABC is an inscribed angle and it is intercepted by which arc? Take the opposite arc. It is intercepted by arc ADC. So inscribed angle ABC is intercepted by arc ADC. Now we will add these two statements. Let us add the left hand side first. So when you add the left hand side, you get angle ADC plus angle ABC, that is here, equal to half is common. So we take half outside. Measure arc ABC plus measure arc ADC. Okay. Now look at measure arc ABC and measure arc ADC. You don't know their measures, but still I've taken it as 360 degree. Why? Because ABC plus ADC total gives you, the whole thing gives you the circle. So angular measure of a circle is 360 degree. So half into 360, you get 180 degree. And what is on the left hand side? Measure angle ADC plus measure angle ABC equal to 180 degree. So I have proved here that this angle D plus angle B equal to 180 degree. And then you can write down, similarly, we can prove angle A plus angle C equal to 180 degree. You need not prove it. You just write down the statement that similarly we can prove. Okay, so I hope you have understood how to prove the opposite angles of a cyclic quadrilateral is 180. So students, with this, we end all the important theorems of circle, 5 important theorems, out of which 10.3 and 10.4 is the most important from all the other theorems. Okay, so in the forthcoming videos, we will be doing lines and angles. So until then, goodbye and take care.